For throwing the books last time, so you with your hand up right here, come up. It seems like I hit somebody in the head. So I'm not allowed to throw books anymore. All right. And then webbots, spiders, and screen scrapers. Wow, this is a real popular book. You with the hat.
All right, dude. Here you go.
All right, before we get started on the talk, we have Tom Brennan from OWASP Foundation. He's going to give a little introduction, and then we're going to go ahead straight into the talk as soon as they get their laptops up and running into PathX, Explosive Security Testing Tools with XPath. So first, Tom Brennan.
Excellent. Good morning, good morning. So I'm Tom Brennan with OWASP, OWASP.org, Open Web Application Security Project. Just wanted to say a quick introduction for both Mon and Andres that they've been phenomenally supportive of the organization. Also, if you don't know, there is an OWASP conference coming up in New York. There's a call for papers out. So Layer 7 Web Application Security, we highly encourage you to submit a paper or a talk. So with that, laptop's working?
Yeah, we just plug it in though.
Oh, okay.
Plugged in? Yeah. Set it down. Thanks, Tom, and welcome. Let me see. Oops. Should be. Oh, my laptop's not working either, it looks like. Yeah, almost. Is that my screen or not?
Oh, it's standard desktop. You gotta slide it over.
Hmm?
Yeah, you gotta slide it over.
Do it.
Just hope it,
It's at 5.
Hold on. What the fuck am I on? This is retarded.
That's weird.
No, dude.
Just move over and press
Yeah.
F5.
Why the hell does it keep going to this one?
Did you hit F5?
Yeah.
Huh.
Fuck.
Huh.
Yeah, we have PowerPoint, right?
What?
You have PowerPoint, right?
Yeah.
Alright,
That's
so
not the
good.
help, is it?
Yeah, why not? PowerPoint's... It's being stupid.
Isn't there just a way to send it, like...
Hold on. No. Stop.
What?
No, don't let me turn off the monitor.
Oh, I don't know. It doesn't.
Alright.
Okay. Well, thank you for waiting.
Sorry about that, guys.
Dar talks about PathX, explosive security testing tools with XPath. Next slide. So there's different ways of doing security testing, different names for it. Some people call it hacking or penetration testing. Some people call it vulnerability assessment, vulnerability finding, vulnerability research, security research. Sometimes I get some interesting questions about how to be a security tester, how to get involved in security testing. There's different ways to improve technique. There's maybe false positives and false negatives, and people always ask me about those types of questions. How do you handle them? How do you deal with type 1, type 2 errors? How do you find an exploit versus a vulnerability? And there's no real simple answer to that because it's a bigger problem. We're not going to address that problem today, but we are going to talk about other issues with security testing tools and knowing when to stop. So these are all fuzzer or fault testing type issues. We're not really going to cover this stuff, but we're going to cover a lot of other things. If you're here to see XPath blind injection or something like that, we're not talking about any of that either. There'll be no active exploits being shown here, but there might be some other interesting stuff. If you're going to get involved in computer security at all, I think that you should go to the MITRE website. They got a lot of good stuff, especially making security measurable.mitre.org. On the CWE site, which is Common Weakness Enumeration, they talk about software weaknesses, which is kind of like classes of vulnerabilities. And they have one section there in the document section. It's called Introduction to Vulnerability Theory, and they try and get into the researcher's instinct, the way security professionals, especially good ones, think about how to solve, how to find vulnerabilities, how to solve security problems, et cetera, et cetera. Let me see. I got some notes here too. So yeah, I have an example of a vulnerability that we found recently, and we're going to talk about that in a second here. But basically, there's lots of other places to find information too, and contacting people working with other people is good. We have a friend locally named Arshan, and on Friday we went and visited him in his office. And when we left, right before we left, I stole something.
And what'd you steal?
We all stole something.
Yeah, we stole Google cookies. So.
Bam. So we found a real vulnerability in Google. The basics of it is that it was not on the top level domain, so we can't share all the details with you. We did responsibly disclose it already. We talked to Google and worked on that type of problem and submitted a bug with them in their tracking system. Basically, CSS was consumed by Google externally. It could be external or embedded XSS that is caused from a style sheet, and they executed and ran it. So it's not a stored XSS, it's just a reflected XSS type. And that's the summary. No. I'm going to talk about it right here. Actually, this is the code for it, so this is how it works. But I'm going to use vulnerability theory to explain how this particular vulnerability works. So there's different artifact labels. This is CWE, Introduction to Vulnerability Theory. And artifact labels basically is a way of describing the locations in the code and in the data. And there's 4 different points, like interaction points, crossover points, trigger points that they talk about. And then the end, the actual payload, is the activation. And anyways, if you take a look at the code, at the top there's a table. And I noticed that the Google text turned a different color. And most people think color vulnerabilities, that's not really that big of a deal. You're just changing the color of something from red to green or whatever. That's exactly what we did. I saw that the Google test, which should probably normally be black, was red. And I'm like, well, I wonder if we could change this to green. And just by changing our external or embedded CSS. So I checked it out, tried it, and it worked. We had it green in no time. So the interaction was, there was some type of interaction between our CSS and the Google site. And that's the actual input. So they were calling our CSS and feeding it into their context, and we're able to change something there. And then I'm like, Martin, check out this vulnerability. And Marcin did the crossover point, which is basically like the place in the code where the vulnerability takes place at. And that would be like the link rel equals style sheet. And so it's just like that's the area where there's a violation occurring in the code. And we went over and talked to Arshan, and kind of like, we already knew that there was probably an XSS in this, but we wanted to see what different types and how far the rabbit hole really went in some way. And so we did a basic XSS which popped up, both alert window and document.cookie with the default privacy Google cookies like UTMZ and all the rest of those. And yeah, sorry we can't show it, but they haven't really, I don't know if they fixed it yet. As far as I know, we just submitted it to their bug tracking system, so anybody could probably use this for abuse. The activation is the actual payload. So in some cases in code, you would see the activation. In this one, you can't. But you can see like the trigger. So the trigger would be at the bottom, the TR first child TD. And so that's the part that is really interesting. That's the part that we affected in order to make the code change, right? There's other places to find information besides MITRE, like OWASP. We already talked about that. WASC, which is the Web Application Security Consortium. I think it's webappsec.org. NIST has a lot of different projects. They have the SAM8 project. They've done all sorts of stuff like over the years in security. Department of Homeland Security has Build Security In, and they work with Cigital on that type of work. And then you can just look at the source code and tools. So what is PathX? Like, basically, we're moving away from ad hoc methods. I know that like you may be familiar with the differences between programmers and security professionals. Well, security professionals and coders have a lot more in common than you think. We're all missing the same types of things. We're all missing like a specialized language, like a way of describing what it is that we do. A clear entry path, like lawyers and doctors and everybody, they have lots of different ways of like, getting into their fields, and it's kind of like a clear way, like, you go to college and, then you go to law school and then you like partner with a firm and then, you start. In security, there's no like real direct path. I mean, like, you can't say you go buy a book or a certain set of books or go to college and become a security professional, become a security vulnerability researcher. There's no clear peer review either. We have like a few journals, like Uninformed Journal, Codebreakers Journal, a few things like that, but it's not like really clearly defined, like it is in medical or law research. And then standards, practices, and procedures. We haven't really done a lot of work with that yet either. In medicine, you say a medical practice or a medical procedure, and people know what you're talking about. If you say a procedure for security testing, there really is none. It's all just ad hoc right now. And there's the notion of cowboy coders, like, people who just, like, they're one-upping each other. Everybody's like, kind of just like wants to be the next big thing and surpass somebody else instead of share and help research. So that's a lot of the problems that we have. Ms. Marcin?
So who we are? My name is Martin Belgashevsky, and this is Andre Geranda. We are TSIsecurity.com, and things that interest us are trusted systems, and we're fanatics about TCSec and NSA Orange Book and Red Book, and we try to apply those concepts that were developed in the late 70s and early 80s to security problems that we have today. So getting more to the testing part of this presentation, we have 3 different layers in our web applications, and we need to understand all 3. First layer that we base everything else on is our content, our HTML. We have content that's delivered from CMS systems, output to HTML, RSS, etc. It's the base for everything else we have. And it makes sure that every user can view the content, because that's really what everyone wants to get at. That's why they're visiting your site, is for the content and the information itself. On top of that, we have formatting and presentation. This is through like CSS, and if it formats the page and changes the look so it's visually appealing. And what CSS has done is introduce scripting capabilities like we showed earlier with MOS binding, and similar is expression in IE. And that brings us to the behavior layer, which controls user interaction and how you're interacting with the web application. And that behavior layer is mostly the reason why web apps are choice of application today, because the ubiquity of a browser and availability on every desktop that you can use, you can access any web app. And so what is XPath? When you load a web page, it's loaded into a document object model. All your P tags, A tags, forms, etc., they get loaded as nodes in the document. And XPath is a way of locating these elements and accessing them. There's 3 ways you can do it. You could use DOM selectors, CSS selectors, and also XPath. And there's just some comparison between a CSS selector and an XPath. Slight variation, not too much. We get the common, some people commonly mistake XPath for regex. XPath is a query language for parsers, and to understand XPath, you got to know a little bit about parsers. But to understand parsers, I would go about thinking XPath like it's a file system. You can navigate the DOM through XPaths using relative and absolute locations, relative and absolute paths. And there's a couple libraries you can use for parsing.
Yeah, so like there's different libraries for different languages. libxml2 was one of the first XML parsers available that was really well done. And it's used primarily in C, but also like Perl and Python, and some other languages use it. Ruby has RexML. And these support different types of parsers, but it's all XML. And then a good one for Java would be XOM. If anybody has any other languages that they're interested in, I could give suggestions.
So this was just some, we're using XML-lint to browse document object model, or browse a web page using XPaths. The top is just like the help menu, but at the bottom we loaded google.com with XML-lint, and we could CD, like change directory to a certain location in the DOM, and we could view it, we could print our current directory, and we could cat it. So basically the same file system utilities that you use to navigate your directory trees, you could use with XML-lint. So that's just to get started with XPaths, just to learn a little bit more. XML-lint. XML-LINT. So this brings us to content parsing. We've all used grep on files, right? Have you ever tried to use grep against HTML or XML, or even viewed XML inside a browser without a style sheet for it? It's not intuitive. It's hard to understand visually, and grep, you're only getting one line at a time. So what we need to do is parse it so we get the bigger picture. And there's several ways of doing that. There's document-based parsers and event-based parsers.
Why isn't HTML greppable?
Well, because you have an opening tag and a closing tag, and some of it's on different lines. It expands longer. So when you grep for something, it comes on just one line.
There's ways of doing it, but it's a hack,
So, and so document-based parsers, they load the entire DOM. You're working with the entire document at a time, and you could do random queries against it. With the event-based parser, you're loading elements, you're getting elements as you need them. It doesn't load the entire document. You could make a comparison with document-based parsers and event-based parsers with cat and tail with -F. So when you cat a file, you print the entire contents to standard out, and you could work with it that way. With event-based parser, to like tail-F, you print to standard output, and you're also waiting for new input. So one thing with event-based parsers to consider, though, is if you run into malformed content, you crash your parser. So we're going to have to clean up the markup and make sure that it validates.
There's two event-based parsers out there, both push and pull types. The push type is typically SAX, and the pull type is usually just called a pull parser. There's like an implementation in Java called Stacks, which is a pull-based parser. Normally, like the libraries that we showed you support all three types, like a DOM tree-based style parser, and a push and a pull parser.
So if you ever dealt with the malformed content, it's not really fun. There's a couple tools we can use to fix our markup, like HTML tidy. The user doesn't see broken markup because our browsers do a pretty good job of fixing that and abstracting that from the user so the web pages aren't broken. Probably IE would be the best example of that, but there's other libraries you can use.
Sure. So there's lots of different libraries for fixing up markup, especially bad HTML markup. If you have valid HTML, that's great, but it's normally really difficult to do. Like, for example, on our website, we had completely valid XHTML on our machine, and it all worked fine. But then when we uploaded it to the server, it was no longer valid, and we can't figure out why. So you're still going to run into lots of situations where you need to have valid markup. And one of the libraries out there that's been known for a while is HTML tidy. It's a C library, but it has bindings for other languages, like even Ruby and Perl and Python and pretty much everything. There's other libraries that kind of encapsulate that concept with parsing, and so they'll do both at the same time. So you don't need an XML parser and a markup fixer separately. Two that I know of are Beautiful Soup and Rubyful Soup, but they're both kind of slow in comparison to other parsers. Some of the best parsers kind of trade off a little bit of efficiency and perfectness and correctness with more speed. Like Nico HTML is one of the best ones. That's what Anti-SAMA uses, and lots of other big projects use Nico HTML, which is mostly Java, but can be externalized from Groovy and other languages as well. Another popular Java one is TagSoup, so those you should definitely know about.
All right, so when we're dealing with malformed content, we need to deal with that before when we're using application drivers there, and that brings us to 3 different drivers we could use. There's protocol drivers. I'm sure a lot of you have used curl. It speaks HTTP back and forth to the server. Some application drivers are HTML unit, JWeb unit, and WebDriver. And there's some difference between application driver and protocol driver is application drivers have some understanding of JavaScript, mostly the logic, but not the behavior part of JavaScript. And a browser driver like what's here, Selenium or WebDriver, they pretty much put your browser into autopilot like Firefox or IE, and because you're using a browser, you're driving your browser, it has a full implementation of JavaScript, so you can do all kinds of stuff in there. So some Firefox stuff we use with XPath stuff and testing. Firebug, I'm sure most of you have used Firebug. We really like XPather. It gets really nice XPath expressions. There's another tool, XPath Checker, but it's more loose in how it identifies an XPath. And you could use XPath Checker with View Source Chart pretty well. And Selenium IDE is an extension for Firefox to use Selenium. And let's see. So we use the XPath extensions to get the location of our elements in our body for when we're testing, and we're going to start building some tests in Selenium. Selenium IDE lets you record and playback your interaction with a web application straight from Firefox. So I would demonstrate it here, but something just, I don't know, tech problems. But we can record it and then play it back, and all our interaction is saved in an HTML table. And because Selenium is a table-driven testing tool, we can make changes to it, and that brings us to let's see. I don't have the screens on here. The screens on here. Shit. All right. That brings us to Selenium Test Runner. Selenium Test Runner actually is just static files with JavaScript on them that you load into a browser web server directory, and you call various test suites that you've created with Selenium IDE. And then you could also add some actions and assertions to your test to perform multiple different things. And then you can run these Selenium tests now from any browser, including IE, Safari, Opera, Firefox, whatever that can support, whatever browser you have that can support JavaScript. We had an example exploiting DOM XSS from the XSS attacks book, the awesome.html that was written by PDP. We did an example of bypassing the input validation with Selenium, setting a cookie in the DOM, and then verifying if the cookie exists, and then deleting the cookie afterwards. The only drawback to doing DOM-based event testing is you have to wait for the entire DOM to load. So your Selenium tests aren't running as fast as it would if you were just looking for the content to be returned. And you got to slow the test down a little bit for DOM-based stuff. Had a demo here, and sorry you guys can't show it unless you have Selenium. No. Excuse me?
What's it? What's the question?
No, so you can bypass well, let's see. Awesome.html.
What we wanted to show with Selenium that we can't show here today because we had to change laptops, and his laptop was not inputting properly, and mine really wasn't either. But basically, what we're trying to show is that the tool is capable of DOM-based XSS. A lot of web application scanners just recently added this functionality, maybe a year ago, maybe a little bit less. And with Selenium, you can actually go in and affect the DOM as much as you want. So any of the JavaScript, any of the CSS, any of the HTML, and you can input things on the DOM that would be running in, say, AJAX applications, or possibly even Flash or other applications like ActionScript languages. So that's what's really interesting about it. It's an open source tool. It's in the browser, and the exploit that we wanted to show is basically from the XSS attacks book. You could download Selenium yourself and probably try out that attack. Marcin figured it out in an afternoon, so it's really not that difficult.
Yeah, it was client-side input validation. It was, PDP was pulling jQuery and just wrote some JavaScript to return back exact name. You input a name, it gets returned back from there. I was running all on localhost, so it's no server-side, but you can do server-side input validation with it.
Yes, but WebScarab is only a protocol driver, so it doesn't have an application driver functionality, so it cannot affect the DOM.
So I wish I could have showed you what the test looks like, but it was literally 44 lines of HTML table. Every event we tested was a single TR table row, and you have your action, what you're affecting, and an argument, and table data cells. It's just a taste of what you can test for. What you really want to be doing is you want to be testing for illegal characters, so like less thans and greater thans. Make sure those aren't being returned to the client, and you want to check for those characters and have them encoded, double encoded, triple encoded, etc. And basically validating input or checking to see if your input validation is working correctly. And you don't have to waste time with an XSS or SQL injection cheat sheet to do this kind of testing. There's no point in working around a blacklist filter or something. If the server will return a less than symbol or anything that's you can start building XSS on, you should assume that it's vulnerable and you should fix it. So that brings us to is taking these tests and integrating them throughout our entire secure SDLC and using them during compilation and at our integration phases as part of AMP build tasks or whatever else. So anytime you compile the program, you just run through the test, make sure nothing gets outputted back that you want and that you don't want. And so here's like a Java example. Selenium will export your HTML test to Java, and that's what our test looked like. It's really simple. You could fire these off to developers. They can integrate it into their integration tests.
And you can see the Selenium click where it has the XPath right there. So that's the XPath for the test.
Yeah.
And this is actually, hold on for a second before you change it, because this is the only thing we have from the test. So this is basically what we were going to show you, except in Java, right? So for those of you in the audience who can read Java, this might help a little bit more than even our demo.
So yeah, what we're doing is opening the awesome HTML, and then we're going to delete whatever cookie was set before as part of our comprehensive test. And then we're just going to type into the name field, document.cookie equals name equals XSS, when it expires, what's its path, etc. And then we're going to do a click, and the click clicks in the XPath for the button that's labeled chat. You can do more specific XPaths, but this is just for simplicity to show. And then we verify that we received the cookie from that, and then we delete it. And it shows in Selenium, as you run it, which ones passed, which ones failed.
And anybody can do this with the tool itself, because it's like play, stop, etc. It's like running a debugger, It's really simple.
And so the thing to take away, though, is developers can make this work. If you don't use Java, there's C#, there's Perl, PHP, Python, and Ruby you could export these tests to. So whatever your language you're developing in, you can run these tests against. And the best thing about using XPath is your tests are now portable. There's multiple open source software and commercial solutions that implement XPath. And we had Tom Strackner from Senzik. We wanted him to come here and show how the XPath implementation in Senzik Hailstorm works. But he was sick and couldn't make it.
So everything's failed so far, but fail is good. Epic fail. So there's other ways of using XPath. We mentioned Selenium and WebDriver already, obviously, but there's other definitely cool ways that you have to check out. Other places in the lifecycle that you can do it in that XPath can help. Maybe you can't use the same exact expressions, but that's kind of like the ultimate goal. In the case of like PMD, which is the project method detector, it's like an inspection engine, so it's kind of like a static source code analyzer, but it really is just a static checker like LINQ, or like lint, not like XML lint, like the actual lint in C. So PMD is like lint for Java. There's a JS lint and other ones, but PMD is probably the best and well known, and it does support customization with XPath. And there are people who have written security checking tools for PMD, which is an open source tool. Runs at the command line, so you could run it as part of like an ant task. And it also runs in IDE. So if you're in Eclipse and you want to inspect your code while you're actually typing it, it'll let you know right away that you've made a mistake. And that's a great tool for finding certain vulnerabilities like SQL injection. And there's some wrappers for that. We talk about it on our website, and I think it's GDS Security. I forget the name of the person who wrote it. I apologize, but
Justin Clark.
it wasn't Justin Clark. We just found out the other night that
Yeah.
it wasn't him. But it was somebody at GS Security who wrote a SQL injection rule set. I think it is in XPath for PMD. Web application scanners, we just mentioned, like, it would be nice if they supported XPath and you could take all of the data from Selenium or WebDriver or another tool and kind of just make it work with web application security scanners. So start with open source and then kind of like move into a commercial product, right? Like that's the kind of idea. Can you think of other places that it might work in the development cycle? Anybody? Well, we'll address them on the next few slides then. So the Selenium examples are table-driven, but they could also be script, data-driven, or capture replay. Ideally, you want to get 100% automation. I know that some people think that automation costs a lot of money. In these cases, these are all open source tools, and so that reduces the cost. Also, the complexity of these tools is a lot lower than quality testing tools used to be. And so people used to say that automation took up like 50, 60% or more of the development budget, and that's just not true today. So that's one thing that we'd like to debunk. It's definitely something that you need to look at. The context-driven school basically is one of the people test-driven development, TDD. If you've heard of that, or behavior-driven development, these concepts want to include testing a lot more in the life cycle, and so. I think that they're slowly winning at even in classically like waterfall type shops. So what's good about this? Okay, the old concepts to new. Everything used to be script driven, like in the 80s and 90s. The first language that I used for testing, like quality testing, that I was familiar with was Tickle. Lots of different people used this. It was big inside Cisco, and like there was like a whole conundrum between San Jose, Cisco, which ran like mostly Tickle and Perl, and then like Austin, who ran like Python. NIST came out with one extension to Tickle, even to help quality testing even further for script-driven testing, called Expect. This was used for a lot of quality testing stuff back in the day. They had one module or like one program that it shipped with called Auto Expect. I used to use this a lot. It basically like wrote the code for you. Like it's a very cool type of like way of programming. I always wondered where's Auto Ruby, because a lot of people compare Tickle to Ruby as kind of like being very similar. I don't know if you've experienced that, but where's Auto Ruby? But I guess we've kind of abandoned script-driven approach to quality testing anyways, and we've kind of moved on to some newer stuff. Next slide. So this is like this is the holy grail of like web automation testing. Can you web test? They have a capture replay part, but it's called like Web Recorder or something. But I don't really suggest using it. I suggest just getting your hands dirty right away and doing some data-driven tests. They have some examples, some screenshots on the website that you should check out. It basically runs as an extension to Ant Builder, and all the tests are written in XML, and so you already got that going. And you can put XPath expressions inside that XML to do all the clicks and on-clicks and whatever DOM-based functionality or other functionality you want. Since it's so close to the integration, and it's so fast because it's an application driver, it's ideal for 100% automation in terms of testing. So basically, like, you could load like an Excel spreadsheet with every single type of fault injection that you want. Like you could throw RSnake's XSS cheat sheet in there, and just like with a few lines of XML, like it's not even programming code, it'll just load it and send it to all the XPath expressions that you want, and basically completely test your entire website for security testing purposes or quality testing purposes or whatever you want. I mean, you decide what the injections are and what you want to see back. Why all these tools? I suggest just using all the tools if you can, whatever you have time for to play with. You can mix and match tools. There's also things called domain-specific languages, which are starting to come around. I know a lot of programmers want to start using them. It's a mix between a tiny language and not really a language at all, like a script or whatever. So it's something like in between, right? It's the difference between like Ruby and C is huge, but like that's coming like a little bit closer. It will be more in the future. XPath is really a specialized language, and so it's one way of describing things. You can use it between tools like we talked about, and we can make it work in different parts of the life cycle.
So let's see, Ryan Gerard and Ramya of of Symantec had introduced the concept of test reputation-based systems or vulnerability reputation-based systems. Basically, it was seeing what the testers, what they found, put it against the developers. So it created two goals for testers and developers. Testers to find more bugs among their peers, and for developers to write better code. And that's part of watching and listening.
So yeah, I'll go into that. Sure. So if you're going to work with other people, I think it's great. Like programmers had this whole thing in Agile where you do pair programming. It didn't really work out that well, and some people still do it, but it's not really that popular. But pair testing is more popular, especially when you're testing for like web application security vulnerabilities or even just any type of software pen testing. Period. At runtime, working with another person is good. So collaborating and watching what they're doing and listening to what they're doing. There's something called the Think Aloud protocol, where you just say, what you're testing, and just like, make it well known that you're actually doing something and talking about, what you see and what you're experiencing. That's a good way of doing this. Then there's also recording. So like we talked about capture replay, which is kind of like recording, but I'm thinking more terms of like taking a video of like what you're doing and putting it on YouTube, or like integrating with someone with Stickam. Like you got something watching your monitor and they got something watching theirs, and you can see each other's monitors. Like Screen used to have this functionality. You can like share screens in all sorts of different ways. I think VNC supports it. So doing that sort of thing, and then like recording like what you're saying as well. So like it could be useful in a podcast later. Imagine like doing like testing, security testing like in a podcast type format. I think that would be interesting. And then, so we already talked about script, data driven, and table type testing. You want to measure all these and kind of like get the reputation. See what the metrics are and how you compare to everybody else, and kind of like increasingly get better and kind of like learn from your friends, learn from your coworkers on how to do better security testing. Another way that's really interesting that I found out about recently is called exploratory testing. I actually heard about it before, but I hadn't really explored it that much in depth. But it's really interesting. Most waterfall type models have all these test cases, and they're really heavy from like the requirement side. And you design all these tests way beforehand, and a lot of times they miss security. So a good way to integrate security into the SDLC late in the process, especially, is to use exploratory testing, which has like a test charter. And the idea is you're writing the tests as you're actually doing the work. So you're basically like hacking the websites, like using the injections, using these types of testing tools, and using your brain to figure out what you want to attack. But at the same time, you're kind of like learning about the application and how it works, and writing down ideas of like how to just test other things. This works especially well with like MITRE's KPEC, where you have like attack paths, and so you can change your attack paths based on what you see in the application, while you're testing it. And so if we measured all these things, if we measured testers and we measured our test cases, we could probably determine what are better tests to do, and better people to use for certain types of tests. So I guess in order to increase the coverage of your testing and your test results, I came across this new concept called combinatorial explosions. It's actually probably been around for a while, but I think there were books about it in maybe as early as 2003. The basic idea, and I think that every single security person probably gets this and has experienced this. And so I know Gary McGraw talks about it in his book, Exploiting Online Games. He calls it combinatorics. And basically, if you induce lag in an application like WoW, you can probably like duplicate items. There's this website, www.wow-dupe.com, where you can go and see how to duplicate items. This works especially well in web applications too. That's what's funny. Like you could basically cause synchronization issues to where you're overloading the application, but at the same time you're checking to see if there's a race condition like time of check, time of use. You could test for deadlocking, live locking conditions. There's a particular testing technique that quality testers use called pairwise, and it includes two basic things. I don't want to dig too deep in them because some of it's math related, but orthogonal arrays and all pairs tables with tester's choice. And so when you combine exploratory testing in the process, all pairs takes like a table, rows and columns, and some of those fields are like question mark, and so you can fill it in like decide which type of test result you want for that, and as you're going along, so you could change that. And yeah, that's really going to help. I think like people talk about fuzzers or fault injectors, and I think Larry Sudo did a paper where like 30% was of applications were covered by typical web application security scanners, and fuzzers have the same type of results. In fact, like most automated testing only gets about 30% coverage of an application. And so like 100% coverage is ideal, but you're probably never really likely going to get there. You should check out Charlie Miller's work on fuzzing and code coverage. But what's interesting about all pairs and orthogonal arrays is that it can increase the coverage by maybe twice that, maybe 60, 70%. So you're getting a lot closer to maximizing the amount of tested inputs and detail in your applications. So this is where we're going to kind of go through the life cycle. I'm going to go through it backwards because typically when you talk about a secure SDLC, you got the steps forward. But typically, I think that we always work from the outside and not from the inside, because we're security professionals. We're not developers, and we have to really work from the outside in. A lot of it is reverse engineering. A lot of what we do, we don't have access to the source code. We're not the ones developing it. So I'm just going to go through kind of the phases of the life cycle in terms of like what quality testers usually do. But just keep in mind that I'm not doing this in the right order. Normally what we start with is operations testing or maintenance testing. It's kind of like after the product's already been released. And fuzzing with code coverage is great. Like I said, check out Charlie Miller's stuff on that. Web application security scanners, that's all like runtime outside of the application, etc. A lot of like financial companies, Gadi Avron talked about this at like 23CCC. They fuzz before purchase, and so before they purchase an application or before they decide on using like an SASS product or whatever, they're going to fuzz test it or run a web application security scanner against it or whatnot. Then there's acceptance testing, which is usually like user based, but from a security perspective, you don't really want to involve the users quite yet. But Selenium is a good approach to that. I like that approach a lot. There's some tools that will help you with this that some vendors have released, like HP DevInspect, IBM AppScan DE, as well as like a few others. Like I think CompuWare has a bounds checker and security checker tools, which will kind of like work at the acceptance testing layer. So this would be for people who want to fuzz their code or fault inject their code before they actually release it. And so, while security professionals are going to do that stuff, there's other things that developers can do or that you can help developers do. I'd like to see a lot of those types of tests translated into these types of tests. But the idea is that during integration testing, when you're actually building the code, so a lot of companies have like a nightly build or weekly build process where they build the code and make sure it actually still compiles and works and functions all together. And even if it's not a compilable language, they just want to make sure it works with the database and with the internet. Maybe it's a stage environment. Maybe it's like some type of QA environment. I think the web test is probably one of the better tools that works in this type of area. So it's tightly integrated with the actual build itself. This is a kind of a gray area, the next one, component testing. Not too many people know about it. Many people still call it just unit testing. But the idea is that you can work with just one component of the application. So if you make it really simple, like you have an internet side, like a web server side, and then like a database server side of a web application, you could mock up or like use a virtual mock, which like is just a fake or like a stub. That's what they normally call, like basically like trying to make the component appear like, appear available without actually like having a full environment to test. And some of these tools are run as integration type tools, but it's kind of like a whole system integration test would involve testing everything, where some integration tests are also component tests. So it's kind of a gray area, and then some of the tools don't run in integration, they run inside the IDE. Like Jetty is like a server that can run in like Eclipse IDE or whatever. There's a Selenium server. This is an interesting project that I just found out about too, which runs on Jetty. And some of the other component testing types, most of these for Java, like Testair and Apache Cactus are both Java, but the Monorails project also supports this. What this is typically known as is a developer pattern called dependency injection. It does like inversion of container, which allows you to do in-container testing. Now, there's a lot of security properties that you can test at this level. I'd like to see people actually doing this, and I'd like to see test cases generated, because the earlier you can find out where these problems are when you're doing a secure SDLC or anything like it, the more safe your code's going to be. As far as typical unit testing, people are always going to say, well, it doesn't work. You can't just do basic unit testing because you can only check for certain things. You can't check for a lot of security properties. You can't do session management. You can look at input validation and special chars, and that's really it. Okay, yeah. Conclusion basically is that security testing should take place in every phase of the life cycle. Like I said, you should generate functional test code from operations and acceptance testing, and XPath will decrease the complexity and allow easier and better information exchange between those layers.
So if you think these, what we presented is like too academic, or it's never going to happen in your dev shop or whatever, I'd like to hear some opinions, what you think, and any other ways of doing it. And the best thing is XPath decreases the complexity of going from one testing tool to another and sharing information. So.
Oh, thank you very much. We'll take questions. Anyone? Sure.
So when you're using XPath to selenium test, and it's driving the browser, isn't it going to be affected by all that client-side validation there? So maybe you press the button and it's on click to the validation. How do you get past that? You're really testing that. You're not testing server-side validation, right?
Correct. Well, that's the whole point of testing with DOM-based XSS, right? That was our example. All of the DOM is on the client side. GNU Web Test is probably better for testing input validation on the server side.
So you're bypassing the client validation, rewriting the DOM so it doesn't exist.
Correct. Yeah. Well, sorry we couldn't show it in the example, but it did work and it was relatively easy to do. Any other questions?
Yeah.
Go ahead.
Go ahead.
You're talking about some of the libraries to clean up HTML, malformation. Do you have
Sure.
any that are in JavaScript itself?
There's like some JS lint projects. There's a whole bunch of them. John Riesig talks about it in his book, Pro JavaScript Techniques. It's from A-Press. That's one good source to go to for those. I think he wrote one of them. jslint.org is probably the main one. As far as you say cleaning up JavaScript or cleaning up HTML? So using the JavaScript to clean up the HTML? Good question. I'll have to look into that. Do you know of one or no? Sure, no, that makes great sense. I mean, thank you for that input. I'll check into it and probably let you know. We will post it on our website, like any of the demos and everything. We have a SWIFT file even with it, so it's something we should have easily been able to show, but since we had to switch laptops and had so many problems with the screen, we weren't able to show it. So yeah, it'll be available on www.tssci-security.com.
Anything else? Questions? All right, well, thank you.
Thanks, guys.
All right, thank you guys for that wonderful talk. We are now closing this room in order to tear it down so we can have our closing panel and our closing talk. So all of you need to get out. You have a half hour to get a snack. You just need to not be in any of the talk rooms. Again, the speaker feedback forms, please give them to any staff member or put them in the box outside of registration. Just not in this room, please.